to for this search a 2D matrix number 2 from LeetCode. Let's jump to the question. Write an efficient algorithm that searches for a value target in an n by n integer matrix. This matrix has the following properties. So first thing first, each row are sorted in ascending from left to right, and each column are sorted in ascending from top to bottom. So this is a sorted matrix that we are going to have, and we have a target value that we need to look for, and if we can find the target value in the matrix, we are going to return true, otherwise we are going to return false. So the first thing that comes to my mind is using a brute force. We use 2 for loops and iterate over every single item that we have in this matrix. But it's going to be quadratic time complexity, and the other thing is we are not using the properties that is given here to us, which is like each row is sorted and each column is sorted. So we should use this, and for doing that, what we can do, we can use 2 pointers. One pointer is pointing at the bottom row and one pointer is pointing at the first column. The reason that we start from here, not here, is because like we are looking for a target value, right? So if the target value is smaller than this, so we can easily eliminate this row, right? But if the target, if we start from here, if the target value is bigger than this, we don't know, it can be any of these rows, so we cannot eliminate anything. But by starting from the bottom, it can help us to eliminate some of the rows and hopefully have less iteration. And so let's go through the code and see how we can do this. So the target value that we are looking for is 12, and this is the matrix that is given to us. First thing, we are going to have the special cases if there is no matrix, or like we don't like the length of rows or columns are 0, so we're going to return false because there is no matrix to look for a target. And then we are going to use 2 pointers. One pointer is pointing at the last row, as you see here, and one pointer is pointing at the first column, as you see here. And we use a while loop, and we decide how to small the scope of search by the value that we are pointing at. So if the value that we are pointing at is equal to target, we're just going to return that. This is the first thing. And the second condition says if this value is bigger than the target, which it is bigger than the target in this case, 18 is bigger than 12, we're just gonna like eliminate this row, and we decrease the row value from, like, let's say this is 0, 1, 2, 3, 4, from 4 to 3. So we're gonna point at this row, and what we are going to do, we go to check to see if the row value is bigger than 0, a column value is smaller than the length of the matrix. And if it is, we are going to check the value that we have here right now is equal to target, which is not equal to target. So what we are going to check if the at row 3 and column 0, the value that we have, which is 10, is equal to 12, and it is not. Or we're going to see if 10 is bigger than 12, which is not. So we are going to add the column number here. So now the column pointer is pointing at this number, and then we are going to check if 13 is equal, which is not. If it is bigger, it is bigger, and if it is bigger, we are going to decrease 1 from the row, so we are going to row number 2, but column number still is pointing at 1, as you see here. And now we check 2 and index 2 and 1, and we see the value is smaller, so we're going to add the column. So now column is pointing at index 2 and row index 2, so 9 and 9 is smaller, so still we're gonna like increase the column number. So now the column number is going to be 3 and row is going to be 2, and we check this value if it is bigger. Yes, it is bigger. So what we're going to do, we are going to decrease the row value, so now it's going to be 1. And now we are going to check at row 1 and column 3, which is 12, and that's the number that we were looking for. So it's equal to target, and we are going to return true. And this is how we solve it, and it's gonna be the at worst case it's gonna be m plus n. M is the number of rows and n is a number of columns, so we iterate over every single item, and the space complexity is going to be 1 because we are not using any extra space. Thank you.